Hi Year 11, thank you for taking the time to watch our video on A-Level Physics. I hope that we do have a few of you who are interested in pursuing A-Level Physics here at FRAM, and if that is the case, then hopefully this video is going to give you all of the information that you need to make sure that you are informed on your choices and decision making. My name is Ms Bartle, and I, along with Mr Tippy and Mrs MacDonald, form part of the A-Level Physics team here at FRAM. You'll see in a second how we split the course up, but generally you will have at least two of us teaching you the course throughout the entire 2 years of A-Level. So you can see here, this is how we divide our course up. We have 8 different topics that form the core content. So from measurements and errors, particles, radiation, waves, mechanics, electricity, more mechanics and thermal physics. We've got fields like gravitational fields, magnetic fields, electrical fields, etc., and nuclear physics forming part of our core content. Some of these things you'll be familiar with already from GCSE, and indeed we do continue to build on them. Then we also have 5 optional subjects from which we can choose in year 13, ranging from astrophysics down to electronics. We usually end up settling on something like turning points in physics because it goes hand in hand with our core material, but there is of course scope, if interested, to expand to one of the other 4 topics. The course for physics is linear, which means that you will sit basically exams at the end of year 13, so there's not really any coursework or there's no kind of modular exams that you are assessed with throughout year 12, although obviously we do have the kind of general end of topic assessments that you'll be familiar with sitting already during GCSE. You can see that we split our assessments up into 3 different papers. They are 2 hours long each. Paper 1, typically you are assessed on the content that you'll cover in year 12 with the additional little bit of periodic motion from further mechanics. Paper 2 tends to be more on thermal physics as well as fields and nuclear physics. And then paper 3, we have a section which is all about practical skills and data analysis, along with the optional module that you have chosen to study. They're all 2-hour exams, and you can see how they're broken down with different types of answers, both long, short and multiple choice answers to choose from. Now, I've mentioned the fact that we do some practical skills and we develop those throughout physics. There are a fair few required practicals that you are asked to complete throughout the 2 years. The practical side of the course runs generally as a pass or fail, and obviously we provide as much guidance as we possibly can to ensure that you do pass that aspect. They're a lot of fun, and they obviously go hand in hand with consolidation of knowledge from the theoretical sides of physics as well. If you are thinking about doing physics at A-Level here at FRAM, then what we do ask you, if you are a triple scientist, is that you gain at least a 6 in your physics exam. If you are a combined scientist, then we ask for 2 5s in your science exams. And because the course does demand quite a lot of mathematical knowledge and skill, we are asking for a level 6 in maths and a level 5 in English, just to ensure that you can understand the problems that you're being asked to solve. Typically, when people come to take physics at A-Level, what we see is that they have taken generally maths alongside that, as well as further maths. We also get a lot of people who take it with chemistry or biology or have come from a more computing background, but we do obviously also have quite a lot of people who come in from other backgrounds as well, so it goes hand in hand with PE, or those who are doing sports science or BTEC PE. We've also got things like history. People study history or politics. It gives them a bit more of a rounded A-Level experience, and we've even had a few come in from music, because actually physics goes really, really well with understanding sounds and musical theory. Physics can open the door to pretty much so many courses at university or for apprenticeships in further education once you're finished school. Typically, obviously, you could go on to study physics at university or a number of different courses as well, astronomy down to geology, loads of different types of engineering, including sound engineering and civil engineering, etc. But I've also put a couple of other subjects on here as well that you might not necessarily have thought that physics went hand in hand with. Typically, physics here is asked as kind of the second science, so obviously these subjects generally have things like the maths or biology that is preferred, but then would ask for a second or third science as well. So things like architecture or dentistry, things like games design, even things like paramedical sciences or medicine, etc., normally ask for physics at least as their second science in your choices. One of the most frustrating things I found when I was at school wanting to pursue physics at university was often you were told that with a physics degree you could find or end up in any career that you chose. And at the time I didn't think that was actually something that was true, but actually having done a physics degree and kind of continued through my physics education, I found out that actually physics lends itself to an awful lot of careers. Some are very kind of easily associated with physics as a degree. Having a look at on the left-hand side there, we've got things like medical physicist or nanotechnologist, so people working with really small bits of physics equipment inside things like your mobile phones or televisions. But actually, the skill set that you gain with studying physics is so wide and varied that it can apply to pretty much any career that you want to turn your hand to. So we have things like patent lawyers who have come out of physics degrees. We've got things like sound technicians or software and app developers. We've got more vocational subjects that go hand in hand with physics, such as electricians or being a plumber. And then even things like doing like science communication or journalism, analysing data, etc., can all go hand in hand with physics as a degree and a career choice. I hope this has helped inform your decision, and good luck with your choices and your exams as well. Thanks for listening.